Okay, so this paper we're going to do first, we're going to do some recapping from grade 10, because your impression that you gave me yesterday was it seemed like you forgot some of it, possibly? Alright, to find a y-intercept, we need to make what equal to what? We got to make the x be 0, which will cause a coordinate to look like this. What would the actual coordinate of the point become? What do we know about this? 0 and then whatever, right? Whatever your y number would be. Okay, so on number 2, what would the y-intercepts be of these questions? Negative 8. This one is 0, 0. So once those are all 0, they would be gone. The second one here, what would the y-intercept of this one be? 0. Good. Because if y equals 0 squared, subtract 8 times 0, there's just 0 left. Okay, when you do y-intercept in these styles, you're going to have to do some work. I'll let you work through that. Okay, go for it. I'll give you a minute. Okay, so here's what we should get. Y minus 5, and then once I put the 0 in, 0 minus 4, negative 4 squared is 16, plus 5. Okay, next one. So if I do my BEDMAS stuff first, 0 minus 2, negative 2, squared is 4. Multiply would be next. And then you subtract and get 8. We were good? And then on this one, so I would do the bracket and exponent parts first. So 0 plus 3 squared is 9. But now is where I attach the outside multiplier. So that's a separate BEDMAS piece. So did we do our BEDMAS stuff? Okay, number 4. If we were to ever find an x-intercept, we need to make y equals 0. So now the coordinate will look like a 0 on the y part. So I made the y turn into 0. Okay, so now when you have this situation, there's no way to isolate that x. You can't get x alone because you have x squareds and x's. So again, like I said yesterday, so then our strategy in math is to factor. Yeah. Factoring and foiling are the complete opposite processes of each other. If you FOIL a factor, you get to the original. If you factor the original. Okay, so this is a simple trinomial, is what I would call this one, because it's got the 3 parts, and it's called simple because it begins with 1x squared. So x times x is how you make your x squared. And then what's your brain going to do? What multiplies to the end and adds to the middle. So 7 times 1. And what do I know about the signs? They would have to be 2 negatives in order to multiply to the positive. So multiplies to that, adds to that. This is not the answer. I want to know what x values. Positive 7, positive 1. So again, that question at this point is, what could I think about x being that would make that 0? What subtract 7 creates a 0? 7 minus 7. Okay, I will tell you that on your tests, I take off communication points. So let's say somebody wrote this on their test. I would deduct them points.
And not y.
Yeah, this on a grid is a point. That's not what I'm looking for. I'm looking for two separate x values. Technically, your points would be 7, 0, and 1, 0. Those would technically be your points. You don't have to write the points if you want to just write the x values, but do you notice that it might not seem like a big deal to you, but that putting brackets on those numbers creates a whole different point. Okay, 0 equals, so we're factoring a simple trinomial. And it's important to write 0 equals because that is the concept. The concept is making y 0. So now you're thinking of two numbers that multiply to 18 and will get you 11 when you add.
2 and 9.
So 2 times 9, and the signs both plus. So that works. So my final answer would be x is a value of -2 or -9. Okay, 0 equals, this is another trinomial, so same idea. Can you think of
5 and 2.
5 times 2 makes 10? And the signs, there's going to be 1 plus and 1 minus because of the -10.
-10.
So the negative has to go on the 5, because remember it's trying to add to a -3. Okay, one more simple trinomial. So another simple trinomial. So what is multiplying to 12? Or -12, I should say. And then you're going to make a, what in the middle actually? A +1. You have to make a +1x. So +1 is what you're trying to make as a number.
4 and 3.
+4, -3. Okay, next example, we're going to switch modes. This is not called a simple trinomial. It was a different type of the factoring that you learned last year.
Different squares.
Not yet.
Square, so it's a
3 letters.
GCF.
GCF. So a GCF is where when you look at it, you say I can take something out that's inside every term. Okay, so there's my 0 for my y. So I'm going to take out what in each term?
1 squared. I mean 1x.
Oh, 1x. So if I divide by x, this would still have an x in it. And if I divide this by x, it would still have a +11. I highly suggest this to even my grade 12s, still struggle with GCF sometimes. Can you multiply that back to the original? That's a good way to check. Did you do your factoring properly? It should always multiply back to that. Okay, this one is -11. But what is the first value for x? So again, I'm trying to think what would make that part be 0. If x was 0. If x was 0, that multiplier would be 0. Okay, can you try the next one on your own? It's the same process. It's a GCF. Okay, check your answer when you're done. Okay, so recognizing what a GCF looks like. Okay, the bottom two are different again. So now we see a difference of squares. Is the other one you learned? So 0 equals, and this style is with 2 brackets. So I think x times x makes x squared. And what times what makes 100 and has to still add to 0 in the middle? Because really, this is technically a trinomial if you want to think about it.
Positive 10, negative 10.
A difference of squares is the same kind of idea as that trinomial part, but there's just a nothing in the middle. So plus 10 and minus 10, because that also adds to 0, right? That's where why that isn't there. Okay, can you try the last one on your own? And then you can look up here when you're done. Okay, if somebody had this written like this way, that's still right. Do we understand? It doesn't matter with multiplication if somebody writes me this or this. Still right. Okay, number 6. The vertex is in relationship to the x-intercepts, where? Where would the vertex be located when you look at your x-intercepts? Where would the vertex be?
In the middle.
In the middle. Directly in the middle. Okay, label each point in words. So this is an x-intercept. Those are x-intercepts. And this point would be a y-intercept. Place a vertex on here somewhere. So where would your vertex
It could be right in the,
go?
above the y.
Above the y?
Not right above, like in the middle between y and the first x.
Right about here is where I'm going to place it. So now I'm going to label it a vertex. And did we notice that the vertex is central in the middle of those x-intercepts? Do you visually see all these things connecting? Okay, so here I would label a y-intercept is that one. And here looks like a vertex. So I need to place 2 x-intercepts to complete this parabola. Where would they go?
They can go on either side. This is a different distance away.
Okay, well,
They can be on the line. Yeah,
they-
they can be on lines. They can be anywhere.
can I put it here though?
Not really.
No, because what would happen?
It has to be like
I'd have to get back to that, and that would be
Right
weird.
between the Y and the vertex, and right in the middle there.
Right in the middle of this?
Yeah, pretty much.
Okay, so if I put that there, I have
Distance
to
on the other side. Yeah.
put this at the same distance. Okay, so again, there's that central part of your vertex. So your x-intercepts are that same distance off of that.